Good day, this is MTH 101, General Mathematics 1. I'll be taking you through study section 14, simultaneous equations. Learning outcomes for study section 14. When you have studied this section, you should be able to define simultaneous equation. You should be able to state the different methods of solving simultaneous equations, such as the elimination method and the substitution method. Also, you will be introduced to the usage of graphical method to solve simultaneous equations. Now, when we talk about simultaneous equation, we are talking about two things happening at the same time. They are happening simultaneously. But let us first of all consider the first method we use in solving simultaneous equations. As you can see from the slide, we have two equations. The first equation is y plus z is equal to 6, while the second equation is 2y minus 4z is equal to 8. And in these equations, you can see that we have two unknowns, which are the y's and the z. So let us see how we can go about using elimination method first to get these two unknowns. Now, how do we go about this in order to find the two unknowns? Remember, we are considering the elimination method. So what you are going to do is to think of a way, through which you will eliminate either the first unknown or the second unknown. In this case, in order to eliminate one unknown, let us multiply equation 1 by 2. Now, after multiplying equation 1 by 2 and equation 2 by 1, let us see how we can go about it. Equation 1 becomes 2y plus 2z is equal to 12, while equation 2 remains the same. 2y minus 4z is equal to 8. It is not compulsory that you use this two values, 2 and 1. You can think of other values, but the main thing is for us to make sure we eliminate one of the unknowns in order to get the second. Remember, we said simultaneous equation is when we have two things happening at the same time. Now, in order to eliminate y, for example, let us subtract equation 1. Let's call this equation 3 now, and this equation 4. Let us subtract equation 3 minus equation 4, and let's see. Now, we have 2y minus 2y. It means that the first unknown is gone. Then you have 2z minus 4z. 2z minus 4z is equal to 12 minus 8. And 12 minus 8 will give us 4. Now, this becomes 2z plus 4z is equal to 4. And at the end of the day, if you add them, your z will be equal to 4 all over 6. And you can simplify that to give you 2 over 3. Now, having done that, since you know the value for z, you can substitute z into equation 1 or equation 2 in order to get your value for y. Let's see how we can do that. Now, when you substituting substitute z into equation 1, you get. Now, substituting z into equation 1, remember that your equation 1 is equal to y plus z is equal to 6, and it means that your y plus 2 over 3 now will give you 6 is equal to 6, and you make y the subject of formula. It means that your y is equal to 6 minus 2 over 3, and from that you can obtain your final value for y and z. Let's go back to the slide. Okay, before we go back to the slide, if you check from the beginning of our equation, you will discover that we multiply equation 1 by the coefficient of equation 2, and we multiply equation 2 by the coefficient of y in equation 1. The main aim of doing this is to eliminate one unknown. Just make sure that you do simple algebraic manipulation in order to eliminate one of the unknowns. For example, you can multiply equation y by 4 and equation 2 by 1 in order to eliminate 0. Okay, let us go through the second method. You know, I said earlier on that we have 3 methods we use for simultaneous equation in order to get our unknowns. And another method is substitution method. This method is not like the elimination method, where you try to eliminate one of the unknown. But in this case, you make one of the unknown the subject of the formula, and after doing that, you go and substitute what the value of that unknown that you made the subject of formula into the next equation in order to get the 2 unknowns. And let us try and solve this example. Now, using substitution method, let us first of all make one unknown in equation 1 the subject of the formula. Now, you know that your 4p plus 3q is equal to 5 from equation 1. 4p is equal to 5 minus 3q. And from that, you can obtain the value for p by dividing both sides by 4. 5 minus 3q is equal to 4. Now, what you are going to do is to substitute for p in equation 2. And let us see what we are going to get, what we are going to obtain from that. Now, remember that equation 2 is 3p plus 5q is equal to 4. Substituting the value of p now, you have 3 into bracket 5 minus 3q all over 4, bracket close, plus 5q is equal to 4. Now you can factorize the bracket, and you have 15 minus 9q all over 4 plus 5q is equal to 4. And from your knowledge of mathematics and BODMAS, you should be able to do this. All you need to do is to find the lowest common, the LCM. Now, after finding the LCM, you have 15 minus 9q plus 20q is equal to 4. And you can multiply both sides by 1 over 4, or you multiply this by 4. So you have 15 minus 9q plus 20q is equal to 16. If you add this, 15 minus plus 11q is equal to 16. And if you want to make q the subject of formula, you get 16 minus 15 in the process. Your 11q is equal to 1. Then your q is equal to 1 for that 11. Now we have gotten one unknown for one of the unknowns, which is q to be 11. So let's see what we are going to do now. What we will do is to substitute for that q into one of the equations to get the value for p. Now remember that from equation 1 we have 4p plus 3q is equal to 5. So what we are going to do is to substitute for the value of q that we've gotten before in order to obtain the value of the second unknown, which is the first unknown, which is p. So So 4p now plus 3 into bracket 1 over 11 is equal to 5. And 4p plus 3 over 11 is equal to 5. 4p, in order to make p the surrogate formula, take this to the right side. 4p minus 3 over 11. And you can, from this place, you can obtain your value for p by finding the LCM. 11, we have 55 minus 3. And your p 4p is equal to 52 over 11. And from this, you can make your p the subject of formula and obtain this, the value for the second unknown. Let's continue. What about another method, the third method, which is the linear graphical method? This is the method of solving two variables by using a range of values. The graph plotted from the values can be used to analyze the results of the equations at the point of intersection between the two straight lines. We are going to work it out now, and you will see how we can obtain our the values for our unknown using this particular method. Let's consider this equation in the example. X plus y is equal to 8 and x minus y is equal to 2. I know that if you were to use the substitution and the elimination method, you will not have a challenge in getting your unknown. But what about the situation where you are asked to use the graphical method? How do you come about it? You know, there are many situations in which scientists and mathematics and engineers and others have to consider problems involving more than one variable, and this is one of the methods. Let's see how we are going to get this. Now, considering this equation, as I said earlier on, let us see how we can use graphical method to obtain the two unknowns, which are x and y. Considering equation 1, x plus y is equal to 8. For x-intercepts, that is when x is equal to 0, y, from the equation, you know that y will be equal to 8. Also, similarly, when y is equal to 0, our x will be equal to 8. All you need to do is to put x to be 0 in equation 1 and put y to be 0 to obtain two values. These two values will be the values will be used to plot the graph later on. Let's consider equation 2, x minus y is equal to 2. For x-intercepts, when x is equal to 0, y is equal to, when x is equal to 0, y is equal to minus 2. And when y is equal to 0, your x will be equal to 2. It means that we've gotten four values now. We've gotten x to be 8, y to be 8, and x to be 2, and y to be minus 2. Now we can use these four values to obtain our graph, and the point of intersection of y and x axis through the graph will give us the unknown value for x and the corresponding value for y. Let's plot the graph and see how it's going to look like. On the graph, your minus x axis is towards the left hand side, while your positive x axis is toward your positive right hand side. Now your y will be the one up, and while this one will be your minus y. And let's take a scale. Let us take a scale. 2, 4, 6, Yes. Now, in picking your scale, make sure that it conforms with the values you obtain for your x, y, for both two conditions. Minus 4, minus 6, and this is a 2, 4, 6. Make sure that you have the same scale for the x and y axis. Now, when x was 8, we put a star for 8, and for y, positive 8, you have, it means that you have those stars. Now, what you do is to join these 2 points together, connect them. Similarly, when we have x to be equal to 2, our y, when x was 2, when x was 2, here, y was minus 2. What you need to do is to join these 2 points, and make sure that while joining, there's a point of intersection between the first graph and the second graph. And from this point of intersection, as you can see it on the slide, that is what gives you, if you trace it to the y-axis and trace it down to the x-axis, those points, that particular point on the x-axis, give you the particular value the value for the x, for the one of the unknown, which is x, and that one which goes to the y-axis gives you the corresponding value for the unknown, for the second unknown, which is y. Now let's go back to the our slide and see what I'm talking about. You can see that was how we obtain our values for x. If you trace that point of intersection to the y-axis, you get the value for y. You get the value for your y, which is the second unknown, and if you trace it down to the x-axis, you get your corresponding value for x. And through that, you can use graphical method to find the two unknowns, which are x and y. Thanks for listening.